charge of putting that one together and picking it out. So. Well, I guess we can go ahead and get going.
Sounds good. So can you guys see my screen?
We can.
Yes.
Awesome.
It's beautiful.
Yeah, I know these are the IntelliFactory colors. They can only be beautiful. All right, so I'm gonna get going. So basically, this is almost like a coding meetup. I mean, we could just actually spend the whole time just looking at code. I think it would be helpful. So instead, I'm gonna just basically kind of introduce what I want to talk about, and then I'll show some screenshots. And I also share the code with you guys through CloudSharper. So you can, if you have a laptop or a machine, and you happen to have CloudSharper on it, then you can actually just follow along and just check in the code and maybe even make changes to see how you can interact with that code base. So yeah, so we're going to use CloudSharper. We could use Visual Studio. Either way, the solutions that you end up editing travel in between CloudSharper and Visual Studio. So basically the same files and the same projects, same file system artifacts will work in both of these editors. So this is what CloudSharper looks like. You guys may have seen a few of the screenshots that we keep posting on Twitter. This is a fairly recent one. This is just straight out of the documentation from CloudSharper. We're running a couple of these interactive documentation pages. This one is about using external libraries in FSI and actually running FSI on the side. As you can see on the right-hand side, we're actually executing those code snippets from the documentation and producing graphs and charts and whatnot. So basically, CloudSharper kind of is meant for quick exploratory programming, as we call it, and also interactive web development and mobile development. So you have this environment that allows you to kind of tap into the world and do some stuff, and then basically use F# for all that. And you have this web-based environment where you can phrase your F# code and little scripts and snippets. And basically, we had made it transparently seamless to go from F# that you type in to actual JavaScript and HTML that you can then visualize and see in front of you. And there's all kinds of different elements, like the interactive is kind of like the interactive you're used to when you use F#, but then there's a whole bunch of others. It's probably best to just refer you guys to another CloudSharper talk if you're more interested. I think we're just going to use CloudSharper today as a vehicle to kind of, you know, ship the project over to you guys so you can play with it. So that's so much about CloudSharper. And about this shipping of projects, if you go to that URL on the right-hand side, and well, you need to sign into a CloudSharper before you do that, or you will be prompted to log in to continue. When you're logged in, this URL will actually show you a or ship a workspace that I guess I have created. And if you clone that workspace, you can basically play with the exact same code. And in this case, this is the your first WebSharper application in 2 minutes, which is a sample section on the WebSharper website. So, you know, a lot of people had like crazy setups on their machines, and you know, when they copy pasted the code from the website, it didn't work because they forgot to change something in web config and things like that. So we decided that, you know, instead of doing all that manually, you can just click on a single link or go to a URL like this, and then you can duplicate the whole project, you can clone the whole project, and you can explore it further. You can open the files and so on and so on, make it compile and so on. And so, by the way, at any time, if you guys have questions, feel free to interrupt, because I think it's better if we make this interactive, other than, you know, me talking for 45 minutes. So, any questions so far?
Doesn't look like it.
Getting a head nod of no.
We're still warming up.
Okay, you guys are warming up.
Waiting for the beer to flow.
Yeah. So you know, if you want to try that URL, you can. So today, and let me introduce what I'm going to be talking about. So as you probably read on the title and the Meetup description, we're going to be talking about reactive application development. And more particularly, we're going to be using WebSharper and one of its newest UI construction libraries called UI.Next. And this UI.Next is basically just another library built on the top of the WebSharper runtime that you can use to model reactive applications, reactive web applications, and reactive web-based mobile applications like single-page applications and so on. So when I was brainstorming for ideas like how to best or most effectively get the points across, I tried to come up with a small example that is small enough so that we don't get lost in the code. Like my size limit was like 250 lines, but big enough so that you can see the benefits. Like you can picture yourself making this application and asking yourself the question, can I do this in my language or my tool, or my web framework, or whatever you're using, in the amount of code and in the amount of effort that we can do it here with, and then go from that conclusion. So let me just introduce this application. Actually, let's just see it in live and how it's running. So I actually have two different versions of this application. And right now, this is the non-reactive version. Can I switch over to what Ryan is saying here? Oh, we are live. Okay. I knew that. So, or at least I was hoping. So this is the non-reactive version, and it's actually based on F# events. And I'll show the code in just a sec. But I want to show you what the application is about. So you can imagine that we have some kind of a electronic store where people can go online and they can buy stuff from us. And in this case, the stuff is like different kinds of computers. We have 3 different categories: laptops, desktops, and netbooks. And 4 items of each. This is totally configurable. I happen to return this collection from the code. I could have just wired this into an external data source or whatever, even my database, but I didn't want to make it too complicated. So here I'm listing these items, and I want to allow the user to put any of these items in the shopping cart. And as you can see on the right hand side, I have an empty shopping cart with a total of 0 at the moment. Then I can go, let's add this Toshiba laptop, and then I get this. And excuse my CSS, it's kind of crappy, it's not aligned and everything, but you can kind of see that I have a quantity of 1 which I can decrement, and then it will disappear, or I can increment, and then I will have that many times that many, giving me a total of whatever dollars. And then I can just remove the whole item as is with using the X button. I don't know why that thing keeps sliding up. So anyway, so I can add a bunch of items, and just to make it more complicated, there's also this little text box where I can say, instead of adding 1, add some other number like 5, and then as you can see, it went from 1 to 6. So this is the application. So it's basically a little shopping cart concept. I can increment and decrement the number of items of each particular kind from in the shopping cart. I can see an aggregated value of my total. I can empty the whole thing, and I can then do a checkout to basically exit from the application and taking the items that I have in the shopping cart and moving to the second step. So basically this is the application. And by the way, this is a client application where we are not going to the server. So this is like it could be running on your mobile, really. So we could basically have a JavaScript call that calls some web service to get these items, and from there on we're running on your mobile phone or tablet, and we don't do page refreshes. As you could see, every interaction point basically leaves you on the same page. It responds immediately, and basically there's no page refreshes, so there's no server post backs and things like that. So this is the application, and let's examine it from a little bit different perspective, and then I want to design this application using a reactive approach. But before I do that, I want to show you how I built this application. And I don't think we should spend too much time in the code, so I'm just going to roughly highlight the different pieces of the code base. Remember, it's about 250 lines, so it's not that big, and you see the whole thing running. So I think it's quite impressive already that you can phrase so much in just so little code. Well, let me switch over here and actually show you what we have. So basically this is what the application looks like. On the left hand side we have all the items for sale, on the right hand side we have the shopping cart. And here are the events that can be triggered. So at any time if I click add to cart on an item, I'm basically triggering an event. And then if I click the minus and the plus buttons, I'm triggering another event. If I click the X or the checkout or the empty cart, I have all other different kinds of events. So altogether we have 2, 4, 6 different kinds of events that we are responding to dynamically, and we are triggering dynamically on demand. Except the final checkout, which is just a synchronous event. It says you click the button and we're leaving, and we're taking your shopping cart to the next step. Every other event basically gets triggered. Certain items or certain pieces of my UI will respond to these events differently. For example, if I add an item, I can actually remove the item so it cannot be added again. Of course, that's not the point of this application. So here we didn't do that. And if I keep triggering any of these events, just certain things keep happening on my screen, and I can just do this forever. And that's the main idea, that we have a shopping cart application with an event backbone where certain kinds of events are triggered and certain consumers of these events are listening to these and acting accordingly. So let's see how we can model this in F#. I'm using Visual Studio, but actually just to be clear about this, you can actually run, wait, here's the link. You can run it on this link in the bottom. So if you go to http google.whatever, you can actually get dropped into CloudSharper, and then you can see the code right there. In fact, let me just show you what will happen. So let me log in here. So I was just showing Ryan here some blogs that we posted on CloudSharper. We just released a new version today, fixing some code service issues, and then there's a whole bunch of other stuff here. I invite anybody to kind of read through these change logs. Usually there are screenshots, like what actually is changed. Like if you just peek into this one, you can see that certain parts of the editor and certain other features are becoming more and more mature. So the whole thing kind of gets quite advanced, and we can already do a whole bunch. And I could just switch all my development to this online tool instead of Visual Studio. So let me log in here. And let's see what we have. So if you had followed those links, you would already be on this very same screen. I didn't, so I need to log in and I need to basically go from there. As you can see, my connection here at home is not the best. Okay, so the first thing, I purposely wanted to do this. I think we had this in San Francisco as well. Somebody says, oh, there's this red thing, and most people don't think, maybe not even read what it says. It kind of just scares them enough so that they don't even read what the message says. It basically claims that we don't have the CloudSharper local component running. So the way you start it is you start typing CloudSharper, if you can type, and then when you find it, you basically start it, and then you get this window on the top of your screen, which basically says running the service, and you can just hide it away. So I didn't kill it, so when you click the exit button, it actually just gets minimized. So now I can tell this to retry, and now it says, okay, I can happily connect to this one machine that serves your workspaces. So let's get a listing of all those workspaces, and as you can tell, I have a few workspaces on this machine. And what we want to do is basically look at a couple of these applications. So I'm going to use this one here. This is the one that you have the link for. And by the way, if you need the link, I can give it to you. Just shout out, and I'll switch back to the PowerPoint. So this is what would happen if you followed the link yourself. We get a welcome screen. You can close that. It would actually be good if you read it, because it gives some basic guidance on how to use CloudSharper. in particular, it actually explains how the build and the deployment process, how the interactive facilities work, how the on-the-fly web compilation works, etc., etc. Maybe this is worth actually trying out. So maybe like if here's a little piece of code that we can send to interactive, then this pop-up kind of comes up and it says starting interactive. I'm going to make this window a bit bigger. And it started interactive, and now it's ready to take the command that I pasted in. So those 2 lines actually produce a button that if you click, it will just do an alert. It says clicked. That's 2 lines of F# code right there. This is actually WebSharper. And similarly, I can type about a dozen lines of code. I can always type here in the bottom. Or you can just click these buttons, send to interactive, and it will send whatever code snippet you are on into the interactive window. So if I send this one, I'm just going to get a chart. In this case, I get 2 charts on the top of each other with some cities and some numbers charted. If you are interested in more about these charting capabilities, there's another documentation page. You can read through that. You can run more charts. There's another one. And these are, by the way, interactive, so I can turn them on and off. There's a lot of things you can do. I could do, for example, mathematical function plotting right here if I wanted. You guys want to do that? I mean, I don't have anything prepared, but just learning from some little basic things like this. So I'm gonna just copy and paste this little code, and then so we have almost like a function, right? So we can observe that instead of doing Alice and Bob and Charles as the X values, I can just pump X values. So I can do something like, okay, well, let's start from an empty chart. So this is going to produce nothing as expected. So in here I can say let's say for all, you know what, let's do something more interesting. Pi, I think this is how you spell it. And then we go by 0 ones all the way to positive pi. And then we return I itself, and then let's say I squared. And boom, we have a parabola. And then you can make this whatever you like. You can make this system.math. It would have helped if we opened that module. So here's x squared and the sign of it. Actually looks like spelled like this, yeah, etc., etc. So here between minus pi and pi, we take increments of 0.01. So we're producing, I don't know, like 680 numbers, and we are basically plotting that many pairs of numbers, and we get this nice function. It's almost a continuous line because we have so many points. If we had decreased maybe to 0.4, then you would see it's more jerky. So that's math function plotting right there for you. So there's a lot of things you can do. So you can imagine that, hey, I can maybe connect to my local database and then chart some numbers from the local database just as easily. It would be almost trivial. And if you are interested in doing that, you should check this other documentation page called using external libraries. For example, you can install a NuGet package in interactive just with a single line, and you can reference it immediately, and then you can use whatever that package is doing. So in this case, I could write interactively a small jQuery mobile application right here in my FSI. And just to top that off, here we have a dozen line of code. What is this doing? So it says it fetches NuGet, a NuGet package called F# data. I think we all know that one. It references it dynamically, and it then uses that to go out to the World Bank database. It gets its context, and using the contexts, it's gonna extract for these countries, United Kingdom, United States, and France, for each of them. So this is what it says, each country. We look at the indicators and the tertiary school enrollment, which is the upper, it's college and university enrollment. And then we're going to map that to year and value pairs and simply just chart them as line charts and combine each country chart into a single chart using the charting combine. So this is almost understandable to a naive person who doesn't even know any F#, but it's actually F# code. And if you run it, it's going to take a little while because now it's going to go out and get the NuGet package. It just fetched it. It's going to use that to actually extract the World Bank database schema, and using that schema it will generate code on the fly and then execute the query using that generated code to actually get the chart. So now we have United States, United Kingdom, and France. The colors are not so different. That's automatic. I guess somehow you can set them, but that's beside the point. Let me go and change something. So first of all, I no longer install this package because I have it already. Plug in Hungary. So as you can see, we immediately get the feedback, and it's quite different. We had for almost 5-6 years a little bit higher school enrollment, and around 2010 it started to fall back, or actually put it in another way, the UK caught up with our secondary or university and college education. Of course, in the US, where everybody goes to college, this is much higher, so it's more like 90%. I think in the EU the general directive is like 75% or 70% to be reached by like 2020. So in Europe, a lot of countries, most people just, they don't go to universities or colleges after high school. They actually get a vocational job, and then therefore the overall school enrollment is a lot less. So you can see that trend, and that's a beautiful little trend. And the beautiful thing is that we extracted it with almost no effort, and it took literally a fraction of a second to get this information visualized using all the capabilities that we have available in FSI in CloudSharper. Okay, but this is not about CloudSharper, so I'm going to close all these. One little nifty thing that you guys may like is that we have the ability to kind of dock these. So this is first of all a pop-up. I can type behind it. I can read the documentation behind it. It just kind of stays on the top. Well, what I can do is I can also dock it in a different side. Like in this case, I docked it to the right-hand side, and I can move my screen to the size I like, and then I can go back and revisit all my stuff that I have been doing. So this could be like an analysis for like a stock trade or transaction or whatever, an investment discovery phase or process where in a few lines of code I discover what I really want to do and then I do it. So that's the point about the F# capabilities. I showed you guys docking. You can kind of rearrange your screen. You can change the layout, as you can see, and it kind of makes some sense in some certain situations to do this. Like if you're developing a mobile application and you want to see the application as you are developing it, you kind of have to divide your screen like this. So anyway, so this is CloudSharper. If you follow the link, you have the shopping cart application. I have it right here. And remember, this is the one using events. And we said we're going to just quickly look at the code and see what we have. So let me check. So this is actually a bit larger than what we wanted because we wanted 250 lines. This is almost 400 lines. This is 370 lines. But there's a whole bunch of stuff about some kind of a thing called a site and a sitelet and skinning. So you can see that some of this code, about 100 lines, is not actually about the shopping cart application. It's just about making the application declared in F#. And I don't want to talk about these sitelets. Like, that's a web thing, and assembling a value that represents the whole website with different pages, etc., etc. But let's just get it running. So let's compile it. So I'm compiling it. I clicked Control B. I could have just gone to the menu and so here's what I did. So here's a build, and then once it's built, I can deploy it using Control D. It detects that it's a sitelet, and it says show it on the deploy screen, which actually will switch out the editor screen and put us on the deployment screen, and there we have our application running. So this is what I was showing you outside. So this was Visual Studio. This is now CloudSharper running it. And as you can see, I can make my page have a different resolution, so I can test the application, how it looks like and how it behaves on different screen resolutions. I can do a whole bunch of other things. All right, so as you can see, here's the application running. There's not too much more to talk about. Maybe just we should, I think, just how this is structured. So remember, I said that this application is not, in the true sense of the word, not a reactive application. However, I claim that it's just as expressive. However, we express that reactivity in a different form, and we used what I called an event hub. And so I don't know how much you guys can actually see that. I should probably make this a bit bigger, shouldn't I?
Yeah.
Okay, so one thing that you can guess will be coming to CloudSharper is the ability to have zooming on the tabs. So here there should be a zoom level, exactly like in Chrome, making this particular code tab bigger in font. But anyway, so these attributes like JavaScript, and there's also another attribute called RPC or remote that stands for a server-side entity that can be called from the client. And because these are all just F# functions, you can just call from one function the other, and WebSharper will take care of the communication protocol, which is the code necessary to communicate between the server and the client. So for you as a developer, all you do is just write F# code and you get nice web applications. You don't even have to worry about JavaScript. You don't ever have to write anything other than F#. So in this, items, which are basically the things that you can buy, they have a name, a title, and a price. And then once they are put in the cart, they become cart item, which means that they carry themselves, but also a quantity and an order in which they had been put into the cart. So the more stuff I put into the cart, I want those to appear on the top of the list. So the order is important in which I add to the add to the shopping cart. And then basically, if I see here, I have an event, a channel, which can have cart event typed values travel on the channel. So this is basically our way of modeling those different events that I showed in the slide. From the different part of the UI, some of these events can be originated, and this is how we model them. We use a discriminated union to say I have all these kinds of events and I call them cart events. I can add an item of a certain kind with a certain number. I can add one of those, I can remove one of those, I can remove a whole item, and I can empty the cart. And remember the sixth event, checkout. I don't have to model that here because a checkout, that's a global synchronous event. It just cuts everything else off. So it's not part of this event hub. It's part of a button and button click handler. So once I have a channel for these events, I can basically, let's show how we, so this is a server, there's a server client application. So in this case, it has an RPC function and computes the different families and the products therein that I have available for purchasing. And where was I? There's a JavaScript module which has some internals. It is like what I see, and it has inner modules for making buttons, etc. It displays all the categories and all the items for sale. And the first thing it does, it goes to the server and asks, can you give me all the families and the products? And then basically iterates through all those families and all the products within the family, and then makes divs and h1 tags, and basically assembles a DOM node which has a complex structure, as you can tell. So if you read WebSharper, you can tell that, for example, the way you construct a DOM node is you have a name which is actually roughly equivalent to the tags in HTML. So here's a p tag, and then you have a list of arguments and a list of inner nodes. That's basically what the syntax is. This is the crazy operator that connects attributes and inner nodes. and then this is another crazy operator that binds an event handler to a DOM element. And in this case, this function web controls a button will return a button as an HTML DOM node, and then here we bind an event handler to it. And actually you can see that this is the add to cart button. So what happens when you click it, we go into our event hub, we generate a cart event called add item, we parameterize it, and this is actually the product that we are iterating on, so it's defined up here in the family that is up here. So we are, remember, recursively mapping all of our families and products within the families into DOM nodes. So we have direct access to whichever item and whichever family we are currently rendering. And those are basically referenced right here. So we have the product title and the price and so on. We make a record, we make a particular shape of the cart event that goes into the event hub, and then we simply trigger that event. So this tells the UI that if somebody clicks the add to cart button for the whatever item, we're going to have an event hub receive a shopping cart event with add item and that particular item that we are talking about. Now, of course, if we have an event channel that is being triggered, so certain events are being pushed to it, nothing really happens as there's a consumer that listens onto those events. So if we, of course, look at the application, what's meant to respond to these events is the right-hand side, the shopping cart summary. So there's another function that actually renders that shopping cart. It's right here. So initially it's an empty div, and then if you go down, it basically will call a function called update cart. Well, I don't have too much real estate to play with, but let's just say that here's the event hub, and this is where we are handling the different incoming events. So first, just whatever items we have, it will asynchronously fetch using the internals. And the whole internals module I didn't show. It's basically a way to encapsulate how we store what you have put into the shopping cart. And in our case, we're using a layer, we're using an inner map that is stored in the page. So if you do a refresh on the page, let's just demonstrate that. So here we have 3 items already in the cart. If I do a refresh, they're going to go away. So we're not using local storage, we're not using persist.js, we're not using anything. We could, but in this case, I actually stripped out from whatever sample I had that whole facility of storing and making the pages persist. So you survive page refreshes. In this case, you don't. But that's the module you would have to modify if you wanted to include that kind of functionality, this internals module. And it has a bunch of other functions, getting all the items, adding another item, removing items, etc., etc. So it basically picks up what I have in my cart and makes a big div with a table that I have into some kind of a DOM structure. And in this case, we have a table that has TDs which have buttons. Like here's the minus button. If I click the minus button, what do? We generate a remove one item event using the product name that is right now being clicked in the shopping cart, and we simply trigger that on the event hub. And if you do a plus, that's incrementing the item. We basically, instead of remove one item, we call the add one item event. And if you want to X the whole thing, so get rid of the item, we just remove the item. So that's 3 different events triggered from a control that is supposed to respond to other events. So the 6 different kinds of events that we discussed originally, some of them are being responded to in the shopping cart, some of them are being responded to in the item list, and some of them get originated from either one of these. So it's kind of like everything is in interaction with everything else. I think we remember that. So this is the price here. So it's 0 at the moment. And once you add something, then you have in the second column, you have these prices appear. Then you have all these buttons, and the buttons trigger events. And now the question is, how come when an event is triggered, this thing updates? Well, that's the next piece of the code. This function that renders our shopping cart not only triggers all these events, and here's more events. If you can see the checkout and the empty cart, sending empty cart, and then sending the checkout, send payment. So that's yet another 2 events being triggered. But in this same function, we also respond to events. And the way you do that is basically registering an event handler on the same hub that is taking these events, and then matching on exactly what has happened. So if we receive an add item, we're going to go into our cart. We're going to check if the item being added exists already, and if so, we're going to get its quantity and increment by whatever quantity the new event tells us to increment or add. Simply store that as a cart item back into the cart. Otherwise, if it doesn't exist yet, we simply just put whatever item with whatever quantity was passed to us, and the order being equal to the next counter, which is this globally increasing counter. So every time you add another item to the shopping cart, this thing gets incremented. So basically, we are handing the event and then adding to our internal map the new cart item, and then we call this function called set. And if you see what set does, it basically goes back to internals and set the items in the cart. And this is what I was referring to, that all the storage details of how we store the details of the shopping cart is inside the internals. So what happens if I have another item or another event? In this case, removing one item from the shopping cart. We find it in the shopping cart. If the quantity of it is less than 1, we simply remove it from the shopping cart. If it's not, then we simply decrement its quantity by 1, and then call set again, which will set persist it in the storage, and nothing visually. And then similarly, if you add an item and you care of removing and adding it, if you empty the cart, we simply set an empty value. So basically now we have a function that responds to all these different kinds of events, but we still need to update the cart once that event has been processed. And because this all of this is taking place with the first thing being a call to the server, which is an asynchronous call, I have to start it as an async. And that's what I do here. So that's in the update cart function. And the very first thing, that before I even draw my shopping cart, I call that function to initialize, get a first visual implementation of the shopping cart, and I simply just return the DOM node that I get as a result. So and at the thing into a site, so I can test it like this. Any questions so far? I think I finished this example. So I'm ready to move on. If you guys have any questions, please ask.
Anybody? Nope, no questions.
Okay, that means it's boring. I told myself I'm going to refrain from showing code, but I couldn't resist. All right, so we're back in CloudSharper. I'm going to switch out from this. Actually, Ryan, can you turn the mic off, because I can hear an echo. I can still hear. Okay, no, it's better. So we were using the cart events. I'm gonna. Okay, my echo came back. So
might be me. How's that?
Yeah, it's better. Thank you. So now I'm gonna switch to the reactive version of this. Not the one using events, but the reactive one. You guys want to tag along? The link is this one here in the bottom. So that will initiate this whole project and clone it on your side, and you can also compile and run it. So let me switch to that. So this is going to basically turn the whole thing, and it just did. It stopped my deployment and loaded this other solution, which is a bundle project, which means it's entirely HTML and JavaScript. So there's no server side. And if you open the code base, we can see that because now we're using a reactive, using UI.Next, we're using a reactive approach, my code base is smaller. It's only 240 lines, somewhat smaller. But this is now within the range that we aimed for. So we had 250 as a limit. And first of all, let's compile this. So you can probably see that it doesn't take too much, maybe like 5, maybe 10 seconds for the whole run. If you do see some slowdowns, like I can actually feel some slowdown, oftentimes it's because of the local component. Like this is way too slow, 11 seconds. So what I do is I go here, and indeed there's something going on with the local server, probably because we didn't stop the previous deployment and it had some DLLs locked. When those DLLs were forcefully shut down, we actually had received some kind of an exception. So there's probably some kind of a CPU spinning issue right now, which, yes, it does happen, and it's something that we are working on. So what I'm going to do is I'm going to stop this. As you can see, the console, as soon as I stop the local services, the ID itself already figured out that I'm disconnected. So I'm going to start it back up, and I'm going to go and reconnect. This is going to reinitialize the whole thing. It says, hey, you modified this. Do you want to reload? Yes. So now we are back. I'm going to do a build again. Well, first of all, we had it built, so it's not going to be that bad. But it actually does perform quite a lot of post-build steps. In this case, it's populating, if you go in the file system view, it's populating this content folder here. It's putting in HTML and CSS and whatever files. All that is generated. So, I think I built. So now I'm ready to deploy. I'm doing Control D, and it detects correctly that this is a pure HTML application, so that's fine. And we want to show it on the deploy screen, but let me show you what else you can do. You can also show it in the browse panel. You can show it in an external browser window, or you can just do nothing. I think I'm going to keep the deploy screen because this is a fairly large real estate requiring application, so I think I'm not going to try to squeeze it into a small little pop-up. Just going to do OK. Now it switches over, and I don't like this resolution. I'm going to go full page. So here's our application. It's slightly different. One difference is these buttons up on the top, and I guess the shopping cart looks a little bit different. So this is what happens if I use the application. Everything works as before. Everything is nicely computed. So now you may ask, why the hell are we needing to do reactive programming here? So let me explain what is reactive. So in this particular thing, if it didn't have any complications, every time I click add to cart, this thing is reacting to it. So indeed, I can actually apply reactive programming for this small application already, because it fits the requirements for being a reactive application, because I do something and another part of the screen reacts to that change. And just like we had these events before, every one of those events can be looked at as a reactive pattern. But I thought I'm not going to stop there. So I'm not just going to not only duplicate the application that we had, and remember it was about 370 lines and now we're down to 240 lines. So we cut down on the amount of code, but I also added more functionality. So let's see what the more functionality is. So my title of my talk is multi-view. So what does multi-view mean? It means this: I can sort by category or I can sort by price. And look what happened. ignore the animation. I'll explain what the animation is in a sec. Instead of showing all these items in categories, like here, we have laptops and we have desktops, then we have more junk down here, netbooks. It actually sorts by price, ignoring what category it belongs to. So this is the multi-view aspect of the talk. And the reactive aspect, other than just basically rewiring this application as a reactive application, I introduced this thing called refresh product prices. And let me show you what this does. So I'm in this one here. So the only change I did with respect to implementing this price, whatever I called it, price refreshing product prices, is just like before, I'm returning all these items, but one of them, this first one, I'm returning not as a fixed number, but I'm returning it as a random number. RND here is defined as taking an int, returning an int, but whatever int we gave, we should actually generate a random number from 0 to that number. So if I go random 1000, I get a random number between 0 and 1000. So that's what this does. So out of all the items, one item will have a random price. So let's see this working. And actually, this will be the Toshiba laptop, the first one. So if you go by sort by category, this is a Toshiba laptop. Everything else will have the same price. So let's check. 1499, 1499, 1499. This is 1066. I refresh the price. Now it's 733, and all the others are the same. Now it's 1080, 1098, 660. So this is kind of meant to, simulate the real life experience that you have on Amazon or Yahoo Travel when you buy a ticket, and by the end of the workflow and just before you pay, Yahoo tells you that the price of your ticket just increased $200. It's not very pleasant, and it almost never goes down. So this is exactly that kind of a situation. So I put that little twist in the application that we not only have a shopping cart where you can actually put some stuff to the shopping cart, and with the value and everything figured out, look at my Toshiba laptops, 2306, two of them. But if I refresh the price and the Toshiba laptop changes down to 316, now this has reacted, the totals have reacted, and this thing also reacted as well. So in other words, this is now a fairly complex reactive situation where I have interdependencies between the different components of my screen. And you probably would expect that this would complicate my code base, but the good news is no, because now we are using UI.Next and not F# events. And with UI.Next, this is not only less complicated, but also it uses up less code as well. So let me show you just a little bit. I learned from the first example. I'm not going to walk. I just want to show you the key parts. So first of all, let's make this somewhat bigger. So it's the usual thing. So I have a module that actually collects my shopping cart model. It has what I call has a source for its image, and it has a family. And then I have a store which computes these products, just like before. Representation of any one of these products when it's put in the cart, just like before. So it has a product. In this case, I'm using just the product code, and it has quantity and order. And for the multi-view aspect, I can sort, which is my multi-view kind of modality thing. I can sort by a category or by the price. And here comes the model. It's 3 lines. I say every time my application does anything, it's going to have a sort mode, it's going to have the products available, and it's going to have the as the variables in the noble sense of the word of my application. So the sort mode can be toggled. The products available will depend on whatever I receive from the server, and the items in the cart will depend on whatever the user put in the cart. So these are indeed my items that, if I look as a discrete entity, their values will at certain points in time change. This is what the literature calls, behavior. It calls it a signal in more recent literature, and more prominent examples of FRP actually call this a signal. These are signals. Except it's not that easy. So with UI.Next, there are different kinds of signals. And in this particular case, we have a variable, which basically just stores one particular type of a value. And in this case, it's a sort mode. So one of these two union cases. But these two guys are actually lists that are being managed by what we call a list model. And without getting into the nutty details, a list model manages the list items using a key. From the products in this case, and the cart items in the other case, how do we actually get the key which we can then use to differentiate between different products and different cart items? And in this case, as you can see, we're using the product code in both of the cases actually. And initially, we even initialize the products available by using a server call to the store. Remember, I modeled this as a client-side call as well. So the store in this case means a client-side entity. So that's my model right there. So what the client does then, it basically has placeholders that depend on the values of these model variables. So let's find the model variable. I see here is do something to the model. In this case, what we see is we have, this is a function in a div. It has an image and a p tag. So the bottom basically is the add to cart. Okay, let's show what it looks like. So here's the H1, here's the price, here's some input, and here's the add to cart. So what happens when we click the add to cart? This is what happens. If the item that we clicked on is not in the cart already, then we add it. But note that instead of sending an event like we did before and registering an event handler that manages some entity inside based on those events, I am here directly writing into the model that in this case represents my items in the cart. And the model, of course, has a function called add, and I can just basically construct an item, a cart item, and pass it to the add function. And this one call basically mutated, produced another instance of the signal, if you will, that represents the items in the cart. So in this discrete line of the values that are, certain times and at different periods change, I just induced a change using the add method, and I mutated that whatever collection I'm maintaining. And if the item that I click on is not in the cart, sorry, this was the not in the cart, then we add it to the cart. If it is in the cart, I have these wonderful functions. I actually added this to and a bunch of other these helper functions to UI.Next today. So the most recent version, the 0.045 or something like that, is the version you need to get these methods. But it has this beautiful function called update by, which can take a cart item and return an option with either a sum showing you what exactly update you want to perform. In this case, we want to keep the P, the cart item, but the quantity should be basically incremented by whatever value is in this input box, which, by the way, I didn't explain this. Let me get back to that in a sec. And if I return a none, that means I just want to remove that item. And here I'm not doing that, but in another instance I will be doing that. So let me just show you a very basic example of a creating like a reactive variable. So here, when I type a number and I say add that, as you can see, this guy went up by 10. So what we actually what has happened is this is a variable. It's actually what we call the reactive variable, but it's being bound to this UI control. So if the control's text changes, we will change because these are linked. So the particular visual representation and the variable that it represents are in tight connection. So if I change the value of this text box, I'm actually updating the value of the model, the variable, the reactive variable that it's connected to. And the way we made that connection is by creating a variable. We initialized it to 1, and in the input field, we simply, if you look at the signature of this function, I meant to say that. If you say it takes a sequence of attributes and a variable that produces a string and returns a doc. And basically, this doc is the type that is a reactive DOM element, and they can be nested in each other. So like here, div is a doc, and we nest inside a bunch of other stuff. These are all nested. So this is basically a connection between a reactive variable and, in this case, an input HTML element. So we basically retrieve the value of this quant reactive variable when you update with the whatever quantity. So basically, when you add, or when you basically add to an existing item, we ask, hey quant, what's your value in this particular moment when somebody clicked the button? And then we retrieve the value and then use that value to actually change the cart items. So here we just saw a reactive variable, a view that it's, or how should I say, we have an unfortunate naming situation here. What we call a view is really what should be called a signal. I'm proposing to the team that we make that change soon. So this is actually a visual representation which normal people call a view. So reactive variable, reactive DOM that is connected to the variable, and then these are basically changes to the underlying, I guess in this case you could call this an observable collection, the items in the cart. And then we perform different operations, either add the new item to it or update an existing one. And the whole code base is very, very simple after this point. So we have product operations. These represent the 3 buttons on the top. So you can see that I just create 3 buttons, like sort by category, and the thing it will do is it will set my sort mode to by category. The other button will set the sort mode, which is part of my model. It's a reactive variable. It will set it to by price. And refresh product prices will go out to the store. It will compute the products with a random price, and then we will set that to our model for the products available. So these are what I call imperative reactive events that are being handled as a, or triggered by a button and handled here as a unit-to-unit function.
Adam?
Yes.
May I ask a question?
Yeah, please do.
So you mentioned that you're changing the state of these things. Are you capturing the history of the state changes, or are you just changing the state in memory somewhere?
We are not keeping the history. So we have an internal data structure which manages the interdependencies between reactive variables and their DOM representations. There could be multiple. And every time there's a change, we simply register the new value. We don't keep a history, which simplifies a lot of things. It actually means more order and more properties that would otherwise be difficult to obtain. But it's also a simplistic model, so you can do a lot of funky things that you could otherwise do if you had history access. So, like in the literature, if you look at RX, for example, they have hot streams and cold streams, and then sometimes you revive a version of like a signal that has produced values in the past, and you want to tag from this point on and join that stream into another stream of changes, but not from the time you made that fork into that other event stream, but from the very beginning. You can do that. I'm not that familiar with any framework that actually keeps a full history, because that would be a disaster. That would be like a garbage collecting hell, and probably a memory leak hell, because there's no way you can actually collect anything, because you never know when in a future time you may need any earlier part of the history. In other words, you just keep generating events and changes, but they cannot be thrown away, and at some point you will run out of memory. In fact, very soon you will run out of memory. So most of these reactive frameworks, they make some kind of a sacrifice. So they simplify what kind of parts of the history you have access to, and typically this is like 0 or 1, or maybe some bounded amount of history depending on some interesting type system properties. So most of these languages that allow you to use a non-1 or a non-0 entries in the history, they typically have some more sophisticated type systems. Like I don't know, session types or whatever. Something that, for example, in F# we don't have. So either you run out of memory easily if you keep history, or you keep history up to 1 value, or you don't keep history. These are your choices in F#. And we had decided not to keep history. You simply, when a reactive variable changes, its current value is then fed to the representations, the visual representations, the reactive DOM that are connected to that reactive variable. But we could keep the one history that was before the change, but we don't do that. Did that answer your question?
It did. Thank you very much.
Okay, no problem. So, I mean, we are contemplating still on changing that design, because there are some benefits from actually keeping that one part of the history that actually was the value before any change. But the use cases are so exotic, and usually you can get around by using your own management of these values yourself. Like here in these functions, before I switch, in this case, the sort mode to something else, like sort by category, I could just save its current value and do something with that. So I could hand manage the history if I wanted to, but we don't automatically provide that kind of history. So if you join an event stream now, you're not going to have access to the previous values of the history. You're going to only have access to the values that are being promoted to that stream of values or changes from that point and on. And only one. Every single time there's a change, you get notified with the current value. That's the only thing we give you. But that seems to be enough for almost everything. In fact, we have yet to find an example where we still would need at least one bit of the history. So far, we haven't managed to find any example where we couldn't work around this limitation. So this seems to be a good model. It makes a striking compromise, but the compromise seems to be a pragmatic compromise. And because of the compromise, we actually can perform a lot of things very efficiently. There's still room for some improvement, of course. And the library itself is growing in different aspects, and we're changing the API, we're standardizing the names and so on and so on. But overall, we had found this to be a pretty effective and pretty good, approximation of what would be an ideal reactive framework. As you can see, the markup you need, the code to actually get something going is very minimal. You define a reactive variable, you connect it to a reactive DOM, and the two are at that point pinned to each other, and any change in either one will cause an update to the other. So let me show you, running out of time, some do with this whole reactive framework. So we have the reactive variables and reactive DOM, but we haven't. And what this does, so this is what I was claiming that shouldn't be called view. This should be really called like a signal. In this case, if you log down to this big function, here we go. You're passing two different signals or streams of changes. One is the sort mode, the other one is the products available. So remember, mode between category and price, and then the refresh button refreshing the products and the price. 2 is basically taking the sort mode and all the products we have, and depending on the sort, we render it using category. So first we go through the products, group them by the product family, and then iterate through all the families, making family divs with stuff inside. You can ignore this bit here because this has to do with the animation. So if I remove this and remove, let's see, probably this. Wait, what did I not remove? Oh, I removed too much. Come on. Is it? Heck, did I remove? Sorry. This is what I wanted to remove. No, I think this actually. No, I didn't do it correctly here. So this is what I. Here we get a warning, so let me get rid of this. So what I'm doing, which are basically annotated as extra attributes on these divs. So now you can see that they are just. In this one we have basically the products that we have rendered from here, and then a closer div that basically clears the flotation stuff. So if I compile this, I'm not going to have any animation. So let's check that. This is how I had the application, and then I figured just a little icing on the cake, I would introduce like these reactive animations. So let's just get refresh. So now if I switch over, I don't get any of these animation stuff anymore. And looks like I removed some class from here, so this actually doesn't float left anymore. These get somehow flushed under each other, but we ignore that little part right now. So as you can see, my cart is incrementing, and every time I refresh the product price, see, items change, the shopping cart updates. If I go back to the category, the only item that should really change in price is this. I think you can see that that's the only item changing price. So this model actually works beautifully once we connect the reactive variables to the reactive DOM, and then using these functions like view2, which allow us to take whatever part of the model we have and actually map it to a visual representation using the values of the collections or the variables being observed. And in this case, we are observing the products and the sort mode, and react accordingly by rendering. As you can see, once I have a function that renders a product, I'm almost set. So the rest is just some styling and putting it in the div and whatever. So that's all minor. And yeah, I think that's it. And then the shopping cart basically is slightly more complex because we have to do, first of all, the same kind of observation based on the two signals, the products available and the items in the cart. And the reason we need that kind of complication is to compute not only the HTML in cart, as you can see, here's the minus button, here's the plus button, here's the X button, here's the title, and here's all the combined quantity times the price. we're doing all this crazy folding and everything so that we can suffix this whole table row with another table row that has the totals. And these totals are computed using the fold and folding that value and figuring out the whole price of all the quantities and all the products. So this is somewhat, I guess, what some people would claim that this is hard to understand. Actually, it's one of the ways to write it, and the function still remains like below like 30 lines of code. And once we have those table rows, we render a little placeholder, and then we have a div with 2 buttons. As you can see, the empty cart just simply clears the cart, and the checkout doesn't do anything. It gives us an alert. It doesn't do anything with the items. So this just gives us an alert, and the empty cart uses the model to clear itself, and then it gets rid of the shopping cart. But no events, no listeners, no triggering. All I have is a reactive model that actually has connections to the UI via these reactive DOM elements, which we expressed, as you saw above, referencing the reactive parts. I'm just trying to find an occurrence. Like right here when we had the reactive variable with the amount of the cart items that you want to add, etc., etc., and basically making this kind of connection, managing everything through a view model or a list model. I'm sorry, and for each of the items inside that list model, rendering the individual products. And that whole management through the list model makes sure that if you changed the value, the reactive value, the whole collection of the products, the visuals will change as well. And that's just an artifact of the system. So you not only get this reactive tie between a variable and a DOM element, but you also manage a list of those, like a collection of these relationships, which almost in every everyday or real life example, you have not one item that has some kind of a visual DOM representation and a reactive pattern to that representation, but you have a list that needs to basically respond to these reactive patterns. So for example, if I remove this, none of my shopping cart is redrawn, but the one item that corresponded to the item that I removed actually performs a minimal amount of the DOM operations to synchronize what changes I applied to the reactive model, to the reactive variables. So I think that's pretty much all the code base. So we went through the shopping cart. It was a little bit tedious here with like about a 50-line block for doing the folding and figuring out the total price. But once I have these guys, I can put the product operation buttons and the items in a div, and then add those into the products placeholder, which actually, if you open the index.html, it's extremely trivial. Here's the products. So we have a typical bootstrap 12 part screen where 2/3 and 1/3 is divided basically into the products and the cart, and then here you can see the first half gets the product and the shopping cart gets the third. And that's pretty much it. Everything else here is generated, so I had to hand add these guys, and everything else was basically in the template already, modulo these links that I had to add as well. And just so that I top this off, I can not only view this in the deployment screen, I can also open the HTML, which I have open here. I can switch to document view, and that renders it as a document. And I can also split the view. And so if I make changes, like let's say I want to reorganize, I say, well, 2/3 and 1/3 is too weird. Let's make it 10 and 12. So as soon as I hit save, it actually resizes, and now you can see that the shopping cart is really tiny, and it doesn't even fit anymore. Of course, if I make this bigger, then it suddenly starts to fit, but now it's actually 10 to 12 or 10 to 2, and I can make the change right here. And once I save, I'm gonna just get instantly the update. So I type this, and boom, there's my update. And there's a couple other things that I could do. So this is a split view. Typically, you want to either have this or just the source view and then view the whole application running on the deployment screen. But another nice way of actually viewing this as you're typing, maybe even the F# code, is right-clicking this and saying Browse. This will open it in the browser, which is a pop-up. I can dock the pop-up to be on the right-hand side. And now I have my application next to the F# code, and there's this little thing here that says on build. It says refresh on build. So if I turn that on and I make some changes to the F# code, and I'm really running out of real estate. Let's say instead of empty cart, I say empty, and then I do a build. Well, this is going to compile with F# and then with WebSharper, and then once it finishes, which it should do now, it refreshes automatically, and as you can see now, it has 3 Ys for the empty cart. So I literally have an environment where I edit F# code here, and as soon as I compile, I get the updated output, which in this case is a web application, next to it. So I can edit F# and see the output immediately. I don't have to do indirect things like, oh, here's the generated JavaScript and HTML. Let's view that here or in a split view. And I think that's about it, as much as I would like to show. Let's see what else we have here. Yeah, if you guys haven't heard about Fish, I always say this. It's one of the community sites we developed using WebSharper. This is an old screenshot, so it really is not the best way to advertise this. And I think that's all. And if you have any questions, I'm happy to answer. And thanks for listening.
Anybody have questions? I don't think so. Thanks so much for your time, Adam. I appreciate it.
Yeah, listen, no problem. It must have been incredibly dry. I think the best thing that you guys can take away from this is following those links from the presentation. In fact, let me bring those up again. So this one is for the reactive application, and then that one is for the non-reactive event-based application. And you guys can just paste that into your browser and get logged into CloudSharper and play with these applications yourselves. So this latter one, the reactive application, is 250 lines, and as you can see, you can edit the F# code, and you get the nice view next to it for the resulting web applications. So this is almost like pure heaven to web developers like ourselves who do everything in F#.
Well, if you send me those links, I'll make sure they're posted on the Meetup as well, so everybody can get access to it.
Yeah, absolutely. I can send you the slides.
Yeah, that'll work too.
Cool, awesome. So thanks guys again. I appreciate the invitation, and hopefully I could show you something that might trigger some of your interests. Actually, so just to conclude, we are using UI.Next almost in every project that we're doing nowadays, and even in CloudSharper. So this whole ID that you see uses UI.Next, and there's a lot of interesting insights and details about how, for example, an application like CloudSharper is structured. And all I have to say is that every single time when we add new features and we look at the total number of the lines that make up the application, it's not getting any bigger. So every time we add more stuff, we kind of do some little refactoring and the whole application gets smaller. And sometimes we change the whole layer of how we display things, and we switch from normal non-reactive DOM to reactive DOM, and suddenly the whole logic of the application becomes a lot smaller, and therefore the code shrinks. So this is actually quite a fun application to be working on. It's really not that big. Of course, now we have invested quite a lot of time in developing it, but there's a lot of things that we haven't really shown anybody yet, and there's a lot of aspects about the cloud-based execution model which we didn't get to see at all. and all that stuff is coming up, and I think we have some awesome things. So this is a full-fledged developer environment, especially if you're working for web and mobile development projects. Maybe I can show you some little mobile sample just before I close. So I'm gonna just basically, here's the 2-minute example. So first of all, let's get rid of the browser. And so we just switched to another workspace. I think the link to this workspace was also in the presentation, so once we post the slides, you guys can get the link. And then you can basically produce this application. So if you break the code, you see that we have red squigglies everywhere. We have code completion. Red squigglies go away. So I can actually use this just like Visual Studio. I can write, this is 40 lines of code. And if you compile it, so remember what I do, I'm just going to browse this because it's already compiled, and here's my little application. Let's tag it here, and there we go. And I can make changes. Like this 4000 really stands out to be too much for 2004. So I make that 400. I do a build. The checkbox here that on build refresh is turned on, so once I have a build, that thing will refresh and it will go back down to 400, which actually we like. So this is almost something that I think most people would feel comfortable editing. This is fairly high level code. I can change the numbers, I can change the different type of chart that I'm doing here. It's all 40 lines and it's all F#. So I make changes and within 3 seconds I have the updated web application running. But I wanted to show you, just before I close, I wanted to show you mobile applications because we never got to see any mobile applications. So let's do a Win.js application. You know, Win.js is, hopefully I have access to my own private feed. Yes, and then we just browse this. Yeah, there's a little phone application. My screen is too small, but you can imagine that this actually, let me just put it on the deployment view. So Control D, and then simple web application on the deployment screen. So here's our little application, and you can save this as a to-do item. It's just saved, and now you have buy milk. You can add another one. And you can see that the animations are kind of nice. So that's what Win.js gives you by default. So you don't have to do anything. Then these guys are done, so you remove them. So this is a small little application, and if you put this on your mobile phone, it looks and functions just perfectly fine. Let's see what else. So we have, here's a mobile application that uses Phone.js. Here's a jQuery UI application. Here's a to-do MVC that I think almost everybody knows. Let's run that. So so we didn't add the HTML, so I'm gonna go to the file system and then browse this. Actually, you know, instead of browsing, I'm just gonna deploy, and then this will flush out the other one and put the to-do MVC. So I need to like buy milk, and then finish, and then let's say I finished my talk, so this is done. In fact, we can even remove it. I bought milk, and saving the world is still to do. And this is basically the app. So before you wonder how big this application is, this uses UI.Next, by the way. So all these are reactive. This is 235 lines with a bunch of comments, so you can quite easily understand. So I typically get the question, where do I get this application? And the answer is that this along with the other ones that I showed you, plus a few more that I have here, plus a whole bunch more that I have on my other machines, and some other people in our company also worked on a bunch of these code snippets. These are actually showcases, as we call them. They're going to be published on the CloudSharper website. So on the homepage, you will get these links, and you can just say, hey, I want to try a Win.js application in CloudSharper, and you click on a link, and then suddenly the whole application is cloned on your machine, and you can run the WinJS application, make changes, publish to your store, whatever. It's all easy. And just to close, here's another mobile application. It uses jQuery mobile. So what happens is, right now, as you can see here in the messages, that instantly we get NuGet packages, because if the build detects that there's a packages config file, it will fetch these NuGet dependencies as the project is loaded. So unlike in Visual Studio, where you have this craziness that you need to restart Visual Studio after a NuGet fetch or NuGet restore, and you have assemblies being locked and things like that, we don't have any kind of craziness. This is very simply just going through all the packages listed, fetching them before initializing the type checker. So now if I open any one of these files, I can actually start typing, and I get the red squigglies, and I have everything correctly. And I can add any kind of NuGet package. So we have a bunch of these applications, like some of these WinJS and the ones I showed you. They actually require a subscription into our WebSharper library, so that you can access those WinJS and PhoneJS, MongoDB, and all these other bindings that we have. And that's it. I think I should let you guys go. So thanks again, and hopefully you will check into CloudSharper. I think it really is worth it. Thank you very much again.
Thanks, Adam. And I see it's almost 5 o'clock in the morning there, so you should probably get some sleep at some point.
Yeah. I'm up fairly late, but this, I guess, is beyond my regular bedtime.
Well, thanks so much for taking the time out to show us.
Thank
Cool.
you.
I enjoyed it. Thank you, guys. Good night. See you guys.